Light is everywhere in our daily life, in offices, at home, and in restaurants. But have we ever thought that such common use of light is actually generating a lot of carbon dioxide, which in turn makes the greenhouse effect even worse? The answer is yes. Therefore, different energy label schemes are introduced to help control the carbon dioxide emission. Just to name a few: US Energy Star, UK Energy Saving Trust, and Hong Kong Energy Label. And to comply with the requirements of these different energy label schemes, I can tell you it's not easy. But it's for the sake of our world, so it's reasonable, isn't it? Today, we're going to visit DEKRA Hong Kong LED Performance Center to see what kind of tests they're doing to verify the compliance of different energy labels requirements. Let's go! In this laboratory, there are 2 testing rooms for live tests and 3 testing equipments. Let's have a look at them one by one. Here we come to a must-have equipment required by US Energy Star, Type C goniophotmeter. It can be used to measure the performance of a directional light source. So if there is a directional light source, there must be a non-directional light source. So what's the difference? Take a look at this spotlight. We will notice that there is an angle of light here. So we say that it's shining to a certain direction. Compare it with a non-directional one. Do we see the difference? The light of the non-directional one is spreading all over without any angle. So it is the presence of such direction of light that requires their performance to be measured by different equipments. So now let's have a closer look at this giant equipment. There are 3 detectors over here. 1, 2, 3. And the 2 mirrors, one, the big one here, and the smaller one over there. They are the soul of this equipment. With them, we can generate different data such as beam angle, light distribution, and color spatial uniformity, etc. All these data are compulsory when applying different energy label schemes we mentioned before. It can also help different lighting manufacturers to design different lighting products, as well as lighting designers to design the use of lights in different locations such as art gallery, hotels, schools, and hospitals. So now let's see how it works. During operation, we can see that its arm is spinning around automatically for the 3 detectors to collect the relevant lighting data from different angles. Then with dedicated software, it can generate the data that we mentioned before and subsequently different report formats such as IES or LDT files. And to ensure test data accuracy, testing must be performed in a completely dark environment. That's why we find that the wall here and even the air conditioner there are all painted in black. They're really professional. So now let's go and have a look at the next equipment. When considering buying a bulb, its efficiency or so-called efficacy, that is, how much light output it can generate per wattage, is one of our concerns. I prefer the most efficient one, that is, the one generating the most light outputs with the same consumption of electricity. Then I have to choose the one showing class A on the energy label. Second concern is its color temperature. For example, if in bathroom, I would like to use a bulb in warm white, that is yellow color, then I have to go for a bulb of color temperature as 2700 K. If in living room, I would like to use a bulb in daylight, that is white color, then I have to go for a bulb of color temperature as 6500 K. Last but not least, its life. Many LED bulbs claim to have 50,000 hour life expectancy, which is around 6 years. With this equipment, after burning it for 6,000 hours, we can measure again its lumen, which is light outputs, and the color temperature. Then we can tell how much its performance depreciates. And this is the 1.5 meter diameter integrated sphere that can help us get all these data. So what's inside the sphere? Let's take a look. The temperature here is always kept at 25 degrees Celsius with allowable deviation of 1 degree Celsius. And the white coating here is a high reflecting substance. First of all, with infinite reflection by the coating, the light of the bulb will be detected by the detector over there. Then the detector will pass the data of each wavelength to this spectrometer for analysis. And after that, the information that we need, such as lumen, which is light output, and color temperature, can be generated. And here we can find a mini integrated sphere with a diameter of 0.3 meter, especially designed for measuring the performance of small light source, such as LED chips. Many bulbs claim to have a long life expectancy. For example, 50,000 hours for LED bulbs or 8,000 hours for energy-saving bulbs. But after such long operation hours, are they really still functioning and still that bright? And therefore, here we have this room for burning them for 6,000 hours to simulate the real-life operation, and this is so-called the live test. After live test burning, we'll measure again its lumen, that is light output, and the color temperature. By comparing the result with the initial measurement, that is before burning, we can tell how much its performance depreciates due to such long operation. If the depreciation is more than a certain extent, the bulb is considered as fail. In fact, many energy labels such as US Energy Stars, US Lighting Facts label, Hong Kong Energy label, and UK Energy Saving Trust all require that the initial lumen and color temperature should be maintained at a certain level after the live test. And here is another live test room which is specially designed for bulbs of 10 wattage or more to apply US Energy Star. The temperature here in this room is always maintained at 45 degrees Celsius or above, and that is the requirement of US Energy Star. Do you find it too shiny and uncomfortable to look at it directly? This is a LED torch. LED is now getting more and more popular and widely used in our daily application due to its high energy efficiency, environmental friendliness, and long life expectancy. However, it could be harmful to our health. According to medical research, LED could be harmful to our eyes and skins, especially its blue light, which may cause cataract and even skin cancer. These hazards make a strong call for IEC committee to introduce the latest standard IEC 62471 photobiological safety in 2009 to regulate and evaluate the quality of LED in the market. And thanks to this great equipment, spectroradiometer. Look at these 4 detectors. 1, 2, 3, and 4. With them, we can generate the irradiance measurement and radiance measurement, and subsequently we can evaluate the hazards that LED may have and classify it as different risk groups. Wow! Now we learned that it really requires high technologies and expertise to perform testing of lights. Thanks DEKRA, they're surely not just a professional, but also pioneer in testing and certification. If you need to verify the performance of your lighting products, go to DEKRA. They can assure you on the safe side. DEKRA on the safe side.